Now, today we have discussed about the computer network layer, why layers, what is layering, and then the last topic should be today's reference model. So first of all, we will discuss why layers. Now, different applications like a telnet, FTP, NFS, and HTTP, they are basically using for file transferring or data transferring. If there is no layer, each new application has to be re-implemented for every network technology. If that, let's consider telnet want to transfer some data, so they are using a different type of transmission media like coaxial cable, fiber optics, packet radio. So, and then if file transfer protocol wants to transfer some files in different system using network, then it is using a different type of transmission media, again coaxial cable, fiber optics, and packet radio. So new application has to be re-implemented for every network technology. If we change the technology, then we need a new application for different applications program. So therefore we need a layer. So what should be the solution of that problem? Introduce an intermediate layer that provides a unique abstraction for various network technologies. There is a one intermediate layer who work for all type of application programs and provide the interface between different type of transmission media. So what is a layering? A technique to organize a network system into a succession of logically distinct entities such that the service provided by one entity is solely based on the service provided by the previous entity. Previous entity means lower level entity. So if we can create a layer, it is the interface between the upper level layer and the lower level layer. So what are the various advantages when we create a layering? Like a modularity, abstract functionality, and the reuse. What is modularity? Protocols easier to manage and maintain. If we are creating a various protocol, it should be managed and maintained easily. Abstract functionality. Lower layer can be changed without affecting the upper layers. Reuse. Upper layers can reuse the functionality provided by lower layers. Now come to the disadvantages of layering: information hiding and inefficient implementation. There is two types of disadvantages. The first one is information hiding and another is inefficient implementation. Next, come to the reference model. ISO OSI reference model. OSI stands for Open System Interconnects, that is the system which are open for communication with other systems. It is developed in March 1978 and by SC16 subcommittee 16 of TC97. This is the Technical Committee 97 data processing of ISO. OSI standard was issued in 1984 as ISO 7498. The OSI model, basically OSI model has 7 layers. We will discuss after that point. What are the principle of layers? Create a new layer where a different level of abstraction is needed. Each layer should perform a well-defined function. Choose layer boundaries to minimize the information flow across the interface, and create enough layers to have a separate layer for each distinct function, but keep the number small enough to make the architecture simple. Now we have elaborated. The first point is create a new layer where a different level of abstraction is needed. When we want abstraction for a particular data, so at that time we can create a new layer. Each layer should perform a well-defined function. If we have a different type of functionality, then we can create a layer and that particular layer define that particular function. What are the various boundaries of that particular layer is to be defined and choose, that is the minimize the information flow across the interface. How much layer we need for a particular architecture, that is also defined. Each distinct function having a separate layer. We can create a separate layer for each distinct functions. The particular OSI ISO layer having a 7 layers. The first one is application, then presentation, session, transport, network layer, data link layer, and the last one is physical layer. That particular layers are working with different type of data unit exchange, like application layer work as an application protocol data unit, it is also called APDU. Presentation layer works in presentation protocol data unit, PPDU. Session layer works in session protocol data unit, SPDU. And transport protocol data unit work as a TPDU. Network layer in the particular or information which is sent by one system to another system. This various data unit exchange are worked. In network layer, our information is converted in a form of packets. In data link layer, that particular packets are divided into a small piece, that is called frame. And the last, in physical layer, it converts in the form of bits. So these are the various data unit exchange of various levels. Now next, what are the functionalities of physical layer? It transmits raw bits over physical communication medium, mechanical, electrical, and procedural standards to access the physical medium, modem to convert between bits and waveforms. Transmission technique like determines whether the encoded bits will be transmitted by baseband, that is the digital baseband, or broadband like analog signaling. So the task of physical layer is it's the responsibility of physical layer to transmit raw bits over physical communication medium, means one system to another system. What are the various access procedure is chosen by the physical medium is mechanical, electrical, and procedural standards. We are using the particular system of modem is modulation and demodulation. It is used in a physical layer. Modem, modulation and demodulation, it is used in physical layer to convert bits to waveform and waveforms into the bits. When we are transmitting our bits, our data or our information, it encoded in the form of baseband or in the form of broadband. Let's come to the next one. It should be the task of data link layer, the functions. Transfer data in the form of frames reliably on point-to-point or multi-access links, that is a medium access sublayer. Also perform functionality like error detection and correction. Automatic repeat request is also there. We are using the automatic repeat request in the form of error detection and correction. Frame sequencing transmits receives frame sequentially. Recreate and recognize frame boundaries using flags. Multiple access protocols, contention, and resolution is also used in that particular data link layer. Frame traffic control tells the transmitting node to back off when no frame buffers are available. Bridges connecting two compatible networks at layer 2. This is called layer 2 data link layer. DLL data link protocol and services depend strongly on the technology used as the physical layer. Now come to the network layer. What are the various tasks of network layer? Transfer and route packets reliably in the communication subnet, which may consist of several networks using different technologies. Routing algorithm like flooding, shortest path, discaster, and something and so on. Congestion control, which is using for a leaky bucket algorithm. Subnet traffic control, use the concept of routers. Network layer intermediate system can instruct a sending station to throttle back its stream transmission when the